Hi friends, today I have a really cool experiment, and this is an experiment about light still, yes, but mostly I'm gonna talk about the cameras. This experiment that I'm gonna do is a pinhole camera, which is a very simple structured experiment that you can do at home. But this one, it came from a kit, and I can assemble it already. But you can create yourself also. It's a really cool experiment. I'll put a link in the description below to how to create your own pinhole camera. So here goes nothing. So I have a recorded video that shows a candle that you see. There's a candle right there as the object. Okay, that is known as the object. And then I don't think I put something there. Obviously, I don't think. But I put something there, which is the pinhole camera. And as you see here, it makes an upside down image. And that is something that we need to talk about. And we'll explain it right now, because this is something that is really cool about it. Alright guys, I'm back, and I have here some things to know about. So this is how I'm gonna explain it with a board. So I'll show you how this upside down image works. So the key components here is the light source, the object, which is the candle, two lines which are actually just boards, but one is something very different than the other. This board right here is called the image plane, or like some sort of a hard surface, because we need the image to hit on something, right? So that's why we need like a plane or a hard surface or board. This, on the other hand, I will talk to you about later. This is something that when we get to the next step. Alright, so to talk about how this works, we have to go to the light source. The light source, what it does is gives some light to an object. Alright? And we know that objects actually are reflectors also. But not like a reflector like a mirror, not like that type of reflector, but also like a reflector itself, because that's how we see around us. So if that's true, then that would mean it can reflect anywhere technically. It's not like it can reflect like only one place. It can reflect anywhere. That is why we can see. It's like a 3D world. It's not a 2D. So it's reflecting all. It's crazy. Okay, there's a lot of light coming from that light source. Okay, so when that happens, there is in a pinhole. There's always a hole, because something that can transmit, something that can go through. So let's say if it was a small hole, just like that, just like the pinhole there was a small, some sort of a transparent thing there. There's a very small circular transparent thing that lets light pass through. So here is called the aperture. This is called the aperture. This small hole. And you know what? I'm going to erase that again because I want to have more space. Aperture. Alright? I'm going to actually do that again. Sorry, it's going to... E. As long as you know what I'm saying, this is called the aperture. Alright? That's the aperture. This small hole right here is called the aperture. Alright? I just want to make that clear. When light comes to that small hole, let's say this is a light ray right here, what it does, it goes to a point where that part from that object will be right here. From that creates that part of the image. Because the light, if it was straight like a like light that can go straight, it'll be blocked because there's nothing to transmit through. So this is an opaque thing. So this is like opaque. This is transparent, you would say, but it's not like actually transparent. You don't have to put a transparent thing there. So that's opaque, and that's like a transparent thing. And if that's true, then that means if we can put it here, but that's blocked. So if it was like right here, that the bottom right here, bottom of this point will be right here. Then here, that's blocked also, so that means they have to be here. It'll be here then. It might be like actually like it's not like very accurate, but you know what it looks like. I'm trying my best to be accurate, alright? This is the best way I can make myself accurate, but it may not be accurate to you guys. But you'll understand what I'm trying to say. So then there's another one right here, which is a little bit like the here. That's why. Because if these dots come together, it creates that full image. So one right here, at the middle obviously. The middle means it will go to the middle. So one right here. And it keeps on going forever. So it'll go right here, 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 and trace back to what part it was from. That's why it works. It creates this image, or I mean upside down image. This is the upside down image. This rectangle right here, I'm gonna say upside down image created. Upside down image created. That's how it works. But now let's I'm gonna erase this back and I'll come back later. Alright guys, I'm back, and I did a little some erase so that we can see it properly again, and I also redrew the candles so that it's more accurate, alright? So, now, you notice something. The aperture's got bigger. It has got bigger. And that's something that's a big problem, because I'm going to explain to you what is actually going to happen. So, as we know, that when a light source comes, it reflects light. So it reflects right here, anywhere it goes, right? So if that is true, then it should go points right here, right here, right here, right here, and more. But since the aperture has got bigger, more reflected light can come. Like say like this point right here, the same point, it doesn't have to go here. It can come here also. More of that reflected light can come to that point and reflect here, right here, right here, anywhere, technically. Even like its own point, it can go anywhere. That's why it's creating a blurry image. Because it's not the points that it's supposed to go. It's disorganized, you would say. That's how you see this blurry image. And it would not work if you have the aperture big. So that's why we want the aperture small. Like this. Very, very small. I'm going to say this. Very small. Has to be very small, so that light can go to a specific point and not going to another point. Like all different types of light coming to a different point. Like this, this, this. Or what I'm trying to say is that, say right here, right? When I said about like this point right here, if we do also another point here, what I'm trying to say is that one point will go right here, right? But it can also go right here. Different light, reflected light can go at any direction. So that's what I'm trying to say. If you have a big aperture, it would create a blurry image, and that's the result. So what is our goal actually about this? Our goal is to make the aperture small so that light, or reflected light to be specific, can pass through to that very small aperture and hit at a specific point so that it can create this very, very clear image. So that is one concept that this camera works. That is one way how a camera works for this, and it's called a pinhole camera. I hope you enjoyed it, and I'll see you next time. Bye!